Hello viewers, in this tutorial we shall be putting you through the nature of quadratic roots using the discriminant. The quadratic equation where y is 0 is of the form ax squared plus bx plus c equals to 0, where the quadratic formula to solve this is given by x equals to minus b plus or minus the square root of b squared minus 4ac over 2a. The expression inside the square root b squared minus 4ac is known as the discriminant. Therefore, the discriminant d is b squared minus 4ac. How do we use this to determine the nature of quadratic roots? Using the discriminant d, depending on its value, there are 4 different natures that the roots of quadratic equations can assume. Number 1, when d is greater than 0. When d is positive, the roots or the solution of quadratic equation are real and distinct. So there are 2 real and distinct or different solutions or roots. Number 2, still when d is greater than 0, but when d is a perfect square other than 0. In this situation, the quadratic equation will also have 2 real and distinct roots. That can be solved by factoring. Therefore, the condition to solve quadratic equations by factoring is when the discriminant is a perfect square. Number 3, when d is equal to 0, then there will be 1 real root. Or sometimes we can say we have 2 repeated roots because the roots will be equal, the roots will be the same. The 4th nature is when d is less than 0. That is when d is negative. The quadratic equation will have 2 imaginary roots. Let us consider these examples. We want to determine the nature of their roots. Number 1, we have 2x squared minus 5x plus 7 equals to 0. So from here, a is 2, b negative 5, and c is 7. The discriminant d equals to b squared minus 4ac, which means the discriminant is negative 5 squared minus 4 times 2 times 7. And that gives 25 minus 56. Here we have negative 31 as the value of the discriminant d. This is negative, less than 0. Therefore, the roots are imaginary. That is, the above quadratic equation, we have imaginary roots. Number 2, in 4x squared plus 4x plus 1, a is 4, b is 4, and c is 1. So the discriminant d is b squared, which is 4 squared, minus 4 times a, which is 4, times c, which is 1. And that gives 16 minus 16. The discriminant is 0. Then the root of this quadratic equation will be just 1 real root, which is repeated. Number 3, comparing with the standard form of quadratic equations, a is 1, the coefficient of x squared, b is 3, the coefficient of x, and c is 1. Applying the discriminant d is 3 squared, which is b squared, minus 4 times a, which is 1, times c, which is 1. So the discriminant is 9 minus 4. Here the discriminant is 5, which is greater than 0. The conclusion about the roots of this quadratic equation is that there are two real and distinct roots. Number 4, comparing with the general form, we have a to the 5, b is negative 3, and c is negative 2. Applying the discriminant d, we have d to be negative 3 squared minus 4 times 5 times minus 2. And this is going to be 9 plus 40 as the product of negative 4, 5, and negative 2. The discriminant here is 49. The conclusion about the root of this is that first and foremost, there are two real and distinct roots. Secondly, because it is a perfect square, the discriminant is a perfect square, it can be solved by factoring. When factored, the left-hand side of the quadratic equation, which is 5x squared minus 3x minus 2, is going to factor out as x minus 1, 5x plus 2 equals to 0, giving solutions of x equals to 1 and x equals to negative 2 over 5. Now, we believe you have seen the 4 different natures that quadratic equations, their roots, can have. If you have not seen any of our previous tutorials on quadratic equations, check the link to the playlist. It's in the description box. Don't forget to like, share, comment your thoughts, and subscribe to this channel. Thank you for watching. Bye.